All right, thank you, Andy. Can you hear me okay? And can you see the slide where it says blank slide number 1 okay?
Yep, can see it and hear you good.
All right, perfect. See, we'll go ahead and get started here. And I'd just like to thank Andy and Central Region for hosting this and doing this guest speaker series. It's a wonderful science sharing and everything, and it's we learn a lot from each other as we kind of go back and look at events and discover the new science and sharing all that. I could make this really fast is we can kind of look at Roger's presentation, and if we just reverse everything, pretty much have what I'm leading into, but we can go ahead and dive into the info and kind of see what I discovered here. And I am, again, Chris Jakub, work at the National Weather Service in Wichita. And I started most of this research back in 2014 and exposed our office folks to it, lucky them. Well, now using this platform, I have this wonderful opportunity to share it with more people. Lately, I've been reading a lot of research on La Nina patterns, and I tell you what, that stuff can be pretty darn addictive. As a meteorologist and living in this prediction world, it must have been something to do with that inner curiosity and possibility of longer range outlooks panning out. Okay, enough of that. The aim for this presentation is to provide you with some awareness signals for increased predictability of future violent tornado outbreaks. We all know it takes the right setup and alignment of favorable environmental ingredients to create these bigger outbreaks. So what I tried to do was decode things from past outbreak events using a simplified big picture approach with only 2 main signals to watch for and figure out the story that it's telling us. I didn't want to really dive into those smaller details and stuff. I just wanted to kind of look back and see if we can kind of see things happening on that big scale and figure out, is this leading to a potential outbreak or not? So let's go ahead and get started. So how did all this research begin? If you ever visited the SBC page and looked at this link, the Violent Tornado Outbreaks link, it was quite fascinating for me, and it sent me down this path of discovery for today's presentation. And once you click on that link, this page has a nicely designed graphical interface where you can click on a bunch of different parameters and look at different times, kind of move forwards and backwards through all these different historical tornado outbreak events. So it's a really well designed platform, and this is where I started everything. So do violent tornado outbreaks share common characteristics? The correct answer is yes, which is a good thing because we can look for those signals to improve our prediction. So what I did for my search criteria period, I looked at tornado outbreaks during the 1980 and 2014 time period, which also included a few historical events where I went back further in time to kind of back test it. So the event criteria I used was the number of strong to violent tornadoes as where to draw this line in the sand for each event and broke them out into the small or big outbreaks. The big events will be our violent tornado outbreaks. So I found 84 small outbreak events, and you had those required 5 to 14 strong tornadoes, with at least one of those being an EF4 or EF5. And then for the big tornado outbreaks, I needed 15 or more strong tornadoes, with at least one of those being an EF4 or EF5, and I had 49 of those events. Using a simplified approach, kind of looking at this big picture thinking, wanted to avoid going deep into the weeds. Since outbreaks are big scale events, I boiled it down to only two signals, the jet stream alignment and magnitude timing of rainfall events in that 12-day period prior to the event. I will explain more about why I chose those two signals in the following slides. So where do we start? There's been a lot of great research done on the tornado environment itself, just wonderful stuff out there. The development of multi-parameter tornado indexes like STP, VTP, which are good at distinguishing the differences of lower end and higher end tornadic environments. So what I did is we will use this type of research and try and reverse engineer the process, going back in time, trying to decode and look for signals on the bigger scale from each of the events and collect all that data to see if it can help us improve predictability of future tornado outbreaks. So keeping things simple, the research started with that reverse engineering of that tornado outbreak environment and narrowing things down to only two signals to follow. Signal number one, no surprise here, strong shear is an important characteristic that is vital for creating these long-lived tornadoes, which typically occurs in the bigger tornado outbreaks. A strong shear creator is the jet stream, and it's something that we can easily follow with the big picture thinking by diagnosing the long and medium range model trends leading up to the event. And we can also look at satellite imagery to kind of help on the day of the event. Signal number two was to look at precipitation magnitude and timing of rainfall events, which included investigation of above or below percent of normal of precipitation and the number of rain days where you had measurable precip in that 12-day period leading up to the event. So why the jet stream? There's a lot of good research on jet streams and tornadoes, and they show a strong correlation with its presence in the region on tornado days compared to non-tornado days. Jet stream influence was especially noticeable for those bigger tornado outbreak events. For each event I looked at, asked a simple question, was a jet stream present, yes or no? And then taking it a step further was to investigate the jet stream alignment and look for any tendencies that could help increase our predictability for a bigger event compared to the smaller events. So kind of diving into this research and just kind of mining out the key takeaways from this research paper was this graphical view showing the appealing relationship with stronger jet stream wind speeds in the month of May present for tornado outbreak days versus these lower wind speeds on the non-tornadic days. However, they just looked at they looked at all the months, but they just kind of grabbed the graphics of the month that has the highest frequency of tornadoes across. But it obviously applies to all months, given other ingredients are in alignment and in place. So why signal 2? Why look at the magnitude and timing of the rainfall events? Is there anything that we can gain from looking at those type of parameters? So again, found some more research on the effects of soil moisture. And we all know that deeper moisture helps boost levels of instability, which is needed for these tornado outbreaks. The wet soil versus dry soil research showed good correlation effects with lower LCL levels and increases on the boundary layer theta E energy. So think of potential increases of CAPE, 0 to 3 CAPE, and this would tend to lead to convective precipitation or more storms are possible in these type of environments. Therefore, I collected data of precipitation for that 12-day period prior to each event to see, is there kind of any tendency that could be discovered leading up to these events? So taking that soil research and its influences on LCL heights and the low energy level increases, using a reverse engineer process, how can we see increased soil moisture potentially modify some of these parameters that are highlighted in green? For example, the STP and the VTP tornado indexes. The friendly thing about precipitation signals nowadays, it can easily be followed and is very easy to track prior to an event using online tools for observed precipitation amounts, percent of normal, and frequency of rain days. I wanted to look at this to see if it could provide an early heads up and increase predictability leading up to a possible event. So how was all this research gathered for these two signals? I will now show some examples of the data collection on the following slides for a few events. Don't obviously want to go through them all, we'd be here all day, but to give you a better feel of how things were done, gathering this data. So looking at signal 2, here's the percent of normal rainfall prior to the big super outbreak of April 3rd, 1974. It turns out it was an active wet pattern with 10 of 12 days seeing measurable rainfall over the region prior to the event. And you can see these values of above normal precipitation during that 12-day period. Some tendencies of note that I want to mention for all these cases was, where did that precipitation fall? All the events that had above normal rainfall, which was about 80% of those events, had the rainfall in the actual tornado target area. The other 20% of above normal rainfall events, the rainfall was either just south of the target area or would be just north of the target area, which meant that deep moisture was already in place, streaming from south to north across or into the target area. So that was a pretty strong signal for the big super outbreak. Let's go ahead and look at a couple of other events. This is the big Palm Sunday outbreak of April 11th, 1965. Again, we see well above normal precipitation, and 8 of the 12 days prior to the event saw measurable rainfall over the region. So it was another good signal, and you can kind of just watch this kind of developing, so it kind of gives you that little bit of awareness or heads up that something might be brewing in the region. Now, we all remember this one. This is one of the more recent events, super outbreaks of the super outbreak of April 27, 2011. Again, another very strong precipitation signal. Well, now I don't have to create hand graphics for these percents above normal. We started to get into the realm of computers now, and we can look at things nicely online. Pretty impressive, widespread, 200 to 600% above normal over the region prior to the event. And I also want to mention, well, some people might say, well, what about all this dryness down here? The thing to keep in mind, the proximity to this heated bath water of the Gulf of Mexico would easily override this dry area. And I don't think it had much of an impact at all. So looking at one more event here, this is the Heston, Kansas F5 violent outbreak for March 13th, 1990. Some very impressive rainfall totals were witnessed prior to this event, especially given the time of year when you're looking at late February into March. And this could be something to watch for in those early season events. You know, are we starting to see an active pattern and we starting to get some pretty decent rainfall in the area, which could give us that early heads up that something might be brewing on the bigger scale. So diving a little bit deeper into the data, this is the number of rain days and kind of a scatter plot. So when you see all these dots on here, don't really kind of look at it as a kind of a pattern recognition between the red dots and the green dots. This is just where all the events fell for each, the small break, outbreaks, and the big outbreaks. The dots on the two charts represent all the events and how many rainfall days occurred for each one of those events during that 12-day period prior to the outbreak. In addition, the dots are colored green and red. Each green dot on the chart represents above normal rainfall for that event, and if it's a red dot, that represents below normal rainfall for that event. And now notice, you see below these charts, these are the percentages for each one of these events of above, below normal rainfall for all the events in that outbreak category. Now, a funny story, when you look at this 50-50, my golf friends, they have this ongoing joke is, with myself being a meteorologist, is they really despise that 50% chance of anything. It's pick a side, choose 40%, 60%. Why do you always choose 50? Well, it turns out in this case, it just happened to fall right again on that midpoint, that dividing line. So sometimes that's just what happens. And I could show them this graphic to show them, see, it really happens. So anyway, moving on, the key takeaway from these charts is the big outbreak events typically have higher number of rain days. 90% of the events had 6 days or greater out of the 12, kind of this above this shaded region. This is where, 90% of the events had 6 days or greater out of that 12-day period with measurable rainfall. So we can kind of contribute that to an active weather pattern is occurring over the area. So there could be some kind of correlation that these bigger outbreaks are manifesting themselves from an active weather pattern. So if you are in a region, you're experiencing an active weather pattern, it kind of creates that awareness that we might want to start watching for the right alignment of everything that could impact this area. And for the box and whisker fans out here, here's how that chart looks for the numbers of measurable rainfall in that 12-day period prior to the event. So the question to ask yourself when you're in this is the active pattern? Is this pattern active? And do we have several days of rainfall occurring? And is the rainfall amounts above normal? Now let's take a look at some of the jet stream data for all the events. Looking at some of the bigger violent outbreaks, I've noticed a strong correlation with the jet stream exit region touching or crossing more orthogonal into the warm sector. Since this signal was happening more frequently, especially on the bigger events, I've heard it called a few other names and decided to give this signature a more suitable label for this presentation and called it the Violent Outbreak Cross, or VOC for short. Now, in the following slides, we're going to take a look at some of these historical violent outbreak events and take notice of how apparent this VOC signature, Violent Outbreak Cross signature, is, and its jet stream exit region alignment being more orthogonal to the warm sector in these events. And this is the big super outbreak. This is your Palm Sunday outbreak. Here's the big super outbreak of April 27th, 2011. Here was our Andover outbreak in the Central Plains across Kansas, Oklahoma, and parts of Nebraska. This is the big Heston outbreak of March 13th, 1990. And it's a pretty strong, consistent signature with this violent outbreak cross, or the VOC. We'll look at a couple more events here. This was the May 4th, 2003 event. This was another event that occurred on March 28th, 1984. And you can tell it's not just something special to the Central Plains, it targets other areas east of the Rockies just as well. Even going back further, looking at May 6th, 1960, or May 5th, 1960. And I'll end on this one, and a lot of you might remember this one, the May 24th, 2011. Again, looking at these bigger events, this violent outbreak cross signature, or the VOC, was very common in these big events. So let's put some percentages and apply it to all the events and see how frequently this happens. So looking at the small outbreaks, kind of looking for the range of 15 to 14 strongest significant tornadoes with at least one significant tornado, here are the jet stream frequencies for all the small outbreak events. 9 of the events had no discernible upper jet associated with them. It was just kind of uniform flow, just like around 40, 50 knots. You still can have tornadoes with that, but these were smaller numbers. 8 of the events kind of had this more meridional pattern, kind of just upstream, just touching or just outside the warm sector. We had 8 of these events. And looking at this projection, we had 13 events where the upper jet was more upstream from the warm sector. We also had 12 events where it was just on the northern edge of the warm sector, still had some influences of the exit region, and I'll show that in a couple slides of frequencies with that. The right entrance region, we had 17 events that occurred just outside the warm sector, kind of more impacting the warm front region. And here's the VOC. This happened a little bit more frequent than all those other jet stream orientations. But looking at the numbers, there's nothing that we can really put our finger on and say, okay, that's pretty obvious. This signature shows up more frequent than the others. They're kind of all over the place a little bit for these smaller events. Well, let's compare that to the bigger events. So now looking at the big outbreak events of at least 15 strong or significant tornadoes, let's look at that violent outbreak cross signature and see how it manifests itself. So we had 4 events of 15 or more tornadoes that occurred in the right entrance region. 1 event that was on the northern edge, just on that northern periphery of the warm sector. We had 4 events where the jet stream was upstream and further to the west of the warm sector. And here's the VOC. 40 of the 49 events had this VOC signature. So it has a very high correlation with these bigger violent tornado outbreaks. This can be something useful for us when watching the model trends of the upper jet alignment and how they are aligning that upper jet with respect to the warm sector. This is something we can use to help increase our prediction for a potential big outbreak event. No real surprise here. This is kind of that upper jet angle for all the small outbreak events and the big outbreak events. you have this kind of veered out upper jet. This is kind of the hot zones, but if you notice, the values are just pretty they're pretty close together, and this is what we would, as meteorologists, to expect to create those deeper levels of shear in the environment. There was just really no good distinction looking at the jet angle, but this is what fell out of the data, and I wanted to look at it just to see if if there might be some signal we can pull out of this. The probability data just wasn't a decisive predictor. So I needed to dig a little bit further into the jet stream characteristics. So I started looking at what region of the jet, the entrance region or the exit region. The signal influence from the approaching jet or the crossing exit region of the jet stream with respect to the warm sector is pretty sound for the small events. And that included, where you're getting the jet's entrance region just right near in the vicinity of the warm sector, but not quite crossing it. Obviously, if it crosses more into it, that creates a stronger signal. And the big jump is when we get into the outbreak, the big outbreak upper jet region, the percentages jump all the way up to 92%. And the other thing of note is tornadoes occurred in both left and right exit regions of the jet stream. So and here's the VOC percentages for each event. Out of the 84 events, the VOC signature in the smaller outbreaks with the smaller number of tornadoes occurred 28.6% of the time. And then in the big outbreaks, the percentage of that VOC signature being present jumped all the way up to 81.6%. So that was a pretty big jump, and it's something just to kind of boost our awareness and kind of look for when we're trying to decipher, is this going to be a smaller type of tornado event, or does this have the potential to be a bigger event when you take all things in consideration, just kind of looking at the precip pattern, is it an active pattern, and these jet stream type dynamics coming into play. So to wrap things up here, just some of the key takeaways and discussion points is looking at those two signals. For tracking these two signals in combination with your other forecasting techniques should help increase your prediction probabilities to decide if this is going to be a bigger event or not. So myself being a pattern recognition person, the data gathered from this research is about the percentages of increasing our predictability. It's not about absolutes. We still need to have other ingredients in alignment for these big events to occur. The data collected from this research and looking at all these events, it tells us kind of a story, and when we're doing the forecast, it's that story, providing, throwing all our forecast expertise and using the tools at our disposal suggests that these bigger outbreaks are coming from an active pattern, which seem to fall out of the precipitation frequency rain days and the higher percentages above normal precipitation in the region. So another question that I wanted to ask and throw out there and answer for folks, just because an area sees above normal precipitation and or a strong jet stream, does that mean a tornado outbreak will occur? No, it doesn't. Just because, like Roger actually showed in 2019, we had just tremendous amounts of rainfall and extensive flooding across the area. It created my awareness and our office awareness that, oh man, we got to kind of watch things here to see if we get the right jet stream and right upper pattern set up that might utilize this type of environment, but that never did come together. We had severe weather, but we just didn't have the right jet structure and alignment of other things to create a bigger tornado event. So that's just another thing to keep in mind. And just because you have a strong jet stream in the area, because we'll see this a lot during the winter months, and you just, a lot of times we're lacking that instability. So you need multiple things to come together to create these scenarios. So again, it's comparing the bigger tornado outbreak characteristics versus the smaller tornado outbreaks. Is look for those higher frequency number of rain days. Am I getting a lot of rain in kind of that 12-day period prior to the event to create the awareness that, you know, we might be looking at something brewing here, which is also falling out of an active weather pattern. So be on the watch. You know, once you see this active weather pattern and it's dumping a bunch of rain in the area or somewhere in the region, a favorable setup could be lurking. And also signal 2, you know, the other signal is look at the tendency of the jet stream exit region and that VOC signature. And model trends are key here, looking at the models to try and see how they are projecting this jet stream coming out with respect to the warm sector, because we can be biased by just, if we're focused on looking at the smaller details, you can really kind of get deep into the weeds there and you might lose sight of the big picture. So I always like to start up, you know, kind of the old funnel approach. Look at the big picture first. Does this kind of make sense? Are the signals kind of coming together? And then we'll work our way down into the smaller details in those parameters to see if this all makes sense. And one last thing I'm going to end on here, and I always like to remind, you know, myself and others, is remember, as meteorologists, we operate in some level of gray area with meteorology. That's just the nature of the beast. And some of our best work comes from improving our forecast tools, like watching presentations like this, looking at research papers and everything, whatever we can do to increase and sharpen our forecast tools for communicating probabilities whether an event will occur or not. And that is pretty much all I have. And thank you, Andy and Central Region, for putting this on. I think this is wonderful stuff where we could do a lot of good science sharing and kind of share all our events with each other and try and learn and improve and sharpen our forecasting skills as we go forward.